All right, so we will go over all the stitching methods available for Keyence. We will start with just a single channel image, and then we will add on the complexity of adding Z-sticks to it, as well as adding multiple channels. So with the single channel, what you can do is you can acquire all of this at low magnification. So using the navigation function, acquire the entire tissue at low mag, and then we will have two different options, either to create stitching using by setting the edge points or by setting the number of images from the center, i.e. 3x3 or 3x4 or so on. So in this situation, I already have set something up with my navigation. So I can go to navigation, go somewhere in the center of my tissue, switch to a 4x objective, and acquire the entire tissue image again. And that's what I'll be doing. Click add, it's gonna go and start scanning. And once I'm happy, I can just stop over here, go back to my image in the navigation panel, zoom in to see what areas I want to acquire. And once I'm happy with one of the areas that I want to stitch, I can go to a higher magnification objective. So for example, let's say I want to acquire this area at high mag. I can go to 40x objective and say, give me, let's say 8x8. It's not going to take a lot of time, so I'll do an 8x8. Adjust my focus. And again, what one can see is this has lots of depth, a lot of Z information, and we will touch base with how to do some Z imaging later on, as well as stitching with Z imaging. Okay. So let's go back to navigation and say I want to get some 8x8. So this is where the stitching is. Anytime you have something blue, it means that's enabled. So I'll go ahead and say 7x5 or 7x6, doesn't really matter much. And you can bring this down. One thing to remember is whatever Z position that you have sat on right now, that Z position will be set as soon as you click the stitching part, okay? So if you were to be somewhere out of focus and then you say, okay, I can again go and set my Z and this is what I want image, you will not get that. You will have to start from in focus. I will, let's say if I'm happy with this focus, I will uncheck my stitch and then again say, do 7x6. And now this is exactly what I'll get. If I set this up with out of focus and then go back to in focus and start stitching, it won't work out. So let's say I'm happy with what I'm seeing. I can close this. Actually, let's keep this open. Kind of minimize it and bring it on the side so you can see while it's imaging what's going on, and hit start capture. It will tell you it's going to create a folder in which everything will be there. So say, okay, yeah, that's fine. It's going to quickly go ahead and, oh, I am doing multicolor rather than not single color. That's okay. So I'm going to pause this and come back towards the end. So once all the images are acquired, this is what comes up. One can go to analyze images, and we can go ahead and turn on the stitch option, whichever it is. Now it's important to know that you are loading the right data set, which is right over here. And let's say, for example, it's not in the right folder. You can close all of this, just showing you where to find this data set. If you can say open image folder, And if you click on this image, it should load up the same options before with the right path. And once that's all set, you can say load. It's going to load through all those images that you had. So as you can see, we will get 4 different images. So let's go ahead and hit say uncompressed. Base channel 1, this is the nuclei based off of what it's doing the stitching, and start stitching. Since our nuclei was at very low intensity, we are getting the shading effects, which usually is not a problem if your images are bright enough. So what you saw is we got 4 images. First 3 images perfectly look fine, and this is in sequential order of your channels. So Dappy, Fitzy, Tritzy, and the 4th channel is a merge of all of them, which we don't care. So I'm gonna exit this out and not save it. The 3rd channel is what I'll start saving as. Now again, the names are very random over here. So you need to know the sequential order of the channels in which your images are opened. So I'll go ahead and say export in the original scale, say okay. I know my last one is, I'll go to my folder and call it analyzed. Open, I'll call this group _5. Let me go back to my folder. Create a folder called group _5. And I meant to save this as Tritzy. Once it's saved, I can close this image. Can save this as Fitzy. And my last one as Dappy. I'm happy with all of them. I can go ahead and open my images in Fiji. Right, and they look perfectly nice. I can zoom into each of them and it's all good. I can merge my channels. Okay. I can adjust the color of each of my channels. So let's say the first one is blue. Again, it's pretty dim, so it doesn't look that great. Right, and then I can merge all of them. And that's how your sample looks like. You can save this. And that's it. All right, so this is with a single channel. What if we have got multiple channels? What happens in that case? So for example, this is what we went over. Let's say if you And we also actually went over part of this, which is acquiring just one area. But what if you want to acquire multiple areas within a big tissue? So let's kind of quickly go over that. And I promise this time I will just use one channel and not multiple channels to speed up the process. So let me go and switch to my single color. Okay. So for example, if this is where we are right now, and I want to take different areas at high mag, right? So I can go and say, okay, I want to be over here. Let me first go and uncheck my stitch, remove all of that. I can select multiple points and start with different stitches. So I can set this point and say set over here, and go and say stitch. Let's say if I'm happy with what I'm seeing. Set center, I'll do like 3 by 3 just to be quick. Okay. Happy over there. I can go to second area. Let's say I'm in focus, I'm happy with this. I can set my second area over here and get the stitch for that as well. And I can go down to this area. Let's say I want to get in focus a little bit. And I'm happy with that and say set. So now I've got 3 different areas that I want to stitch. And once I'm happy, say start capture. And it's going to create a new group, which will have 3 different folders for each of these positions, XY1, XY2, and XY3. That's how it works. I'll say okay. And boom, 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 you will see it's going to different areas, 1, 2, 3. And we are done. Open the folder. I can go to XY. Well, that was only one image. I did not get all of them, so that was my fault. But XY02, I have these images over here, right? I can load them, uncompress, start stitching, and boom, we're a stitched image. I'm going to save that, cancel, same thing, go to my third position, load that. Let me see if I'm at the right place, right? So I'm at XY02, which is not the right position. So make sure you are in the right folder. Now I'm in XY03, so that's the right folder. Load that, uncompressed, and stitch, and you get this image, right? So straightforward, easy. You can do multiple channels if you want to with this as well. So in this situation, you will go back and select multicolor, all your channels, and pretty much repeat the same process. All right. All right, so in the next step, I'll show how to capture Z-stacks and do stitching. And on Keyence, once you stitch the Z-stacks, you have the option to get maximum intensity projection or a max contrast image. What does that mean? What that means is when you do max intensity projection, typically it's the brightest pixel in the Z direction that is projected on your single image, which is your maximum projection image. Keyence also has an option of giving you a standard image in which the maximum contrast of the particular pixel is projected on your final image. In contrast, in case of best focus image, let's say if you have a tissue section which is going from left to right, and it's a thin section, but there is some tilt in your slide, and what you have on the left is in focus, but on the right is not in focus, and you still want to capture the entire slide. In that situation, you can acquire multiple Z images, and at the end, when you are generating an image, use the best focus, and the system will figure out which image plane is in focus to give you an image which is best in focus. And probably I'll show this with one of an H&E image at the end as well. But for the moment, we will stick to the slide that we have in the scope right now. All right. So let's go ahead and jump to that. So let's go back to Keyence. This time I'll probably use a 20x objective to demonstrate that. I'll uncheck all my multi-points. I don't want them. Uncheck my stitching and start with, let's say, probably a 20x objective. So even with the 20x objective, we can see that there is good enough of a depth in our sample. You know what? I'll switch to 40 because 40 will give us even better depth compared to 20x objective. So I take it back. I'll switch to 40x. So now we can see this nice depth of the tissue. And there is more depth in this area of the sample compared to the other area that I was. So let's keep it at that. All right. So now you can see all the different cells coming up. I'll turn on Z-stack. Pitch is the difference in the Z, the height of the Z sections. So this is pretty thick. I'll set the upper and the lower limits, which is the top and the bottom of your tissue that you want to image. Let's say I'm happy with this. I'll set the upper limit. And that's something, the position, that's something you can read over here and over here. Okay, so that's my upper limit. I'll go down in my tissue and set my lower limit, which is right over here. And as you can see, this is about 100 microns in thickness. So I'll just do every 10 microns, and I still end up acquiring 10 images. So if I'm happy with this, what I can do is go to stitching and say I want to acquire, let's say, a 5x5 area, okay? So I'm acquiring a 5x5 area over here and say, let's start capture. And I'm gonna switch this over here so you can see how quickly it's moving through the Z. So I'll start capture. It will create a new group. That's okay. And say, fine by me. And it's quickly going through the Z. And while it's going to the Z, we can see all the positions it's acquiring as well. And it's pretty fast. Almost at the end of the capture. And we can go back and analyze our images once this menu opens. And once this menu is up, we can say, okay, now you also get the Z-stack option. You can scroll through your Z-stacks, right? And you can say, I also want to stitch. And once you say, I want to stitch, it gives you all these options, which is full focus and best focus. That's the one that we talked about earlier. Let's start with full focus. And I'll only show, let's say, do a standard one where the contrast in the image is projected at the end and not the maximum intensity. You kind of got the idea of how this works. So I'm just only going to show the standard image. So I'll say, okay. It's going to read through all the images that you have acquired. And once it's all done, the same thing, uncompressed, start stitching. And boom, right? So as expected, you will get many more nuclei here. I'm done with this, so cancel, versus this is what you see in one image, right? You have few nuclei, but when you look at this image, you have many, many, many nuclei present, okay? And once the image is there, you can do file, export in original scale, say okay, and just gonna save it over here. And this is my max projection, contrast. And while we are here, might as well as do the other options as well so that we can compare how each of the images look like, right? So let's go back to full focus and do max intensity projection again. Then uncompressed and start stitching. So once this is stitched, I'll again go ahead and save it, and just call it max projection. Just call it max projection and say save. So that's all good. And let's try the last one, which is the best focus. This is way more quicker because it doesn't have to go through as many images as the other options. Uncompress, start stitching. And I get this image over here. Just put in the original scale. And this is my best focus. So let's compare each of those images in Fiji and see how they look like. Okay, so compared to max projection versus max contrast, there is less of background in max contrast versus in max projection. This one looks much more cleaner and smoother compared to what you get with max projection. One thing that you would notice is Keyence automatically converts your 8-bit image into an RGB image, which is unfortunate, but that's what it is, okay? And let's compare all of this with best focus. And if you compare your images with best focus, clearly you have fewer cells in best focus, right? Because you are only selecting one plane versus multiple sections. So let's say if I draw an ROI for just this area so that we can compare apples to apples, and I can use the same ROI over here. If I zoom into it and look at number of cells over here versus number of cells over here, clearly you can see we are picking up one section which has got this nice bright nuclei versus this one has got multiple nuclei overlapping each other compared to best focus, okay? So hopefully you kind of got an idea of what's happening with different options when you are selecting this in Keyence. All right, so we covered up all of this in nutshell. I went and covered up all of these options. If you have any questions, you can reach out to us. We will be able to help you. There is one last thing that I'll show you towards the end, and that's for H&E images, so hang in there. In the continuation, I'll talk a bit about how to set up H&E or color imaging for your slides, which may have tissues which are labeled with H&E or some other colorimetric methods. And we'll also demonstrate the stitching part of that, okay? All right, so for color, make sure that you have one of the filter sets taken out. And in the original settings, for example, right here, let me close this. And here, which is in the filter cube itself, you have selected Brightfield and not fluorescence for the filter that you have taken out. Okay, so I have taken out a fluorescence filter set from position number 4 in the microscope, and I'll change that to Brightfield. And once that's all set, I'll go back to my capture images, go back to acquiring Brightfield image with color and a particular kind of an objective that you want. Now it's going to ask you the white balance. So you need to set your square where you have complete white area. I have my white area over here. And when I say okay, you can also play with this a little bit and things will change, but you don't want to bring your square onto your color. And you saw that my color got a bit messed up. So I'm again gonna go to white balance and bring it where my white region is and say set to that, okay? Well, now it's saying it's too bright. So I'm going to reduce my exposure so that the system can identify something. So now it's okay, and I can increase my exposure a little bit. I can change my amount of light that's coming out and so on, right? So this image looks perfectly fine now. I can use navigation to go ahead and scan my entire image. Okay, and once you're happy with what you're seeing, I can go ahead and say, okay, I want to acquire, let's go back to my 4th one. Okay, so this is my image. I want to go ahead and acquire some of this regions at high magnification, similar to what we did before. So you kind of got the idea. We can go and set something over here using a 20x objective. And set the focus, right? So come back the right focal plane. Now, if you're not very happy with the color, you can readjust your white color. So this is super bright right now. So now I'm not saturated. So I can again turn on the white balance. It will give this square, bring it to the white area, set it, and now you get nice, vibrant looking colors, okay? These are nice haplotypes that we are looking over here. And let's say I want to now do some set edge points. So I can click on stitching. Let's say I want to stitch a small area from here to here. I can set my edge points. Let's say I want to do it from here. I want to image something till here, set those edge points, and then hit acquire. And it's going to acquire all of this region, right? So that's just one image that I'm acquiring, which is straightforward. So let's say if I start capture and say, okay. It's gonna quickly go ahead and acquire data for me. First, I'm going to analyze images, the same thing that we saw before. load this image. Uncompress, start stitching. And we got our stitched image, right? So same thing, we can save this image the way we did before, and it looks awesome, right? We can see individual nuclei, cells, and so on. So same thing you would do, file, export in original scale, and call it H&E. One, and save that. Let's X out of here. Cancel all of this. And look at the example that I started this conversation with, which is doing some Z on this image sets, right? So if I go from, let's say, for example, here to somewhere over here, I am losing my focus, right? So how do I compensate for something like this? So let's just do an example, uncheck all the stitching. And so I want to acquire something from here all the way to here. I can turn on my Z stack, figure out my Z positions. So let's say, where am I right now? All right, so going back, I know that as I move from here all the way to somewhere over here, I'm losing my focus a bit, or we can pick a better region somewhere, let's say, more pronounced here till here. So that's in focus. And as I move more towards left, I'm losing focus. So how do we compensate for this? So we can go to Z stack and figure out our Z positions. So this is 3088.4, and let's figure out this, which one is top and bottom. And this is 3097. So this is our top. So I'll go ahead and set this up as my upper limit, come back to this region, which is about 3088 or 89, and set that as my lower limit. And I'm happy with that, right? And it's gonna acquire about 6 images. I don't need to do every 1 micron apart. I can do 2 micron apart and say, okay, but we also need to set my region over here. So I'll turn on stitching and say, this is my first position. This is my last position. So these are the number of images I'm going to acquire. And now let's go ahead and start acquiring. This should be quick. Right, so we are acquiring different Z positions every 2 micrometer apart. As you may see, some of the sections are in focus, some sections are not in focus. And we will use the best focus option at the end to get all these sections which are in focus. And that's where the power of best focus comes into picture. So I'm gonna go ahead and analyze images. Of course, I want to stitch them as well. Well, Z stack and stitch. So I will do best focus. Don't want it for 1. I want for all of them. So stitch, best focus. It's loading all the images and say uncompressed, uh, start stitching. And now if I zoom in into our image, let me just save this info, and we can look at this in Fiji. So if I go and look at these images again, my Fiji is sleeping. Give it a second for it to wake up. Okay, Duncan over here. And now if we look at, if we zoom into the image in this region, it's a little blurry towards the end, but by and large, uh, it's still in focus. I mean, it's blurry because we are at the point where it's going to be blurry. It's a 20x objective, low NA, and that's how it's going to look at. Also, it's got pixelated, but this is what you want to compare from edge to edge. And edge to edge, it looks perfectly fine. There is no um, loss of focus from edge to edge. Okay, so that's what we are interested in. All right. So that's where power of best focus comes into picture. And yeah, that's pretty much it. All right.